Inverse function. Inverse function is a very tricky topic, and I found that at times it becomes very difficult to find inverse of a function. So in this set of videos, I'll take different techniques which can be applied to find inverse of a function. The best which I like is reversing operations, which I'm going to discuss just now with you. And before getting into those details, let me show you how really reversing operations work, right? Then you'll get appreciation of what we are really trying to do. And I hope you will enjoy the rest of the videos and be an expert on inverse functions. So here we have taken a very simple example. It says given function f of x equals to 2x minus 1. Explain how the reversing of operations works to find inverse of a function. So this is what I like to explain you here, and let's do it and then let's see what really happens. So what is a function? When we say function f of x equals to 2x minus 1, what does that mean? So function basically is an input-output machine. Think it like an input-output machine. So let's put this box here and we'll call this as our function, right? That box is a function, and let me just write here f for function here. So this is a function which performs some operation on input, right? So that means we have an input from here, and when you have input from this side, you get output on the other side of this box. You get output. So basic operation of the function is to perform an operation on input, and normally inputs are numbers, and in this case they are real numbers. So input is a set of real numbers which gets into the function, and function will operate on it, perform this operation and provide us the output. So normally, as given here, input is this x, the independent variable, and output is dependent on the independent variable. So output is y. The output is y, and y is the value of the function when x is the input, right? That is how we have to see. So here, if the input is x, then the output is f of x. So that is how things are related. Now f of x for us in this particular example has been defined as 2x minus 1. Now when we say f of x is 2x minus 1, it really means that when a function gets an input, then operations are performed on it. So in this case, two operations are performed. First operation is times 2, and the second operation is minus 1, right? So let me write down these operations here to show you what things are going on. So first operation is times 2, right? So we'll say times 2, and the second operation is minus 1. So these are the two operations which are performed on the input, and so we see that the input, which comes as x value, gets multiplied by 2, and then we subtract minus 1, and then we give output, which is f of x, right? Now what I will do is I'll show you how it really works, so that you get a feel of it. Now I'll put set of inputs here and set of outputs on this side. Let us say my input x is 0. Now if my input is 0, 0 times 2 is 0, 0 minus 1 is minus 1, so I get an output which I'm writing as f of 0 is equal to minus 1, correct? If you plug in the value here also, you'll get the same answer. That is what we have done. Now if I put an input of 1, then 1 gets multiplied by 2. So 2 minus 1 is 1. So f of 1 was given as 1, correct? Now if I give an input of 2, then 2 times 2 is 4. 4 minus 1 is 3. So f of 2 is 3. Similarly, if I give more inputs, let us say if I give an input of 10, so 10 times 2 is 20, and we get 20 minus 1 as 19 our result, and that is the result of 10 as the input, right? So likewise, we can give inputs and we will get corresponding outputs. So that is the operation of a function, right? Now what is inverse of a function? Inverse of a function really is reversing the whole operation. When we say inverse of a function, that means what we are expecting the machine to do is reversal. That means if I send -1 now from here, then a performance of operation should be done on this so that we get 0 as output. Do you understand? So that is what we are calling as inverse of a function. Now as you can see here, we can do inverse of a function by reversing the operation. Now how to reverse this operation? Now think about these boxes now. What will they do? Earlier they did some operation. So while processing, function multiplied by 2 the input value and took away 1. Now reversal should be what? Logically, reversal should be just reverse of that. So what should we do here? When we get input from this side and we have to perform inverse of a function, then we should do reverse of the operation. That is, we should add 1 and then divide by 2. If I do that, I should get my input back. That's the whole idea. So the whole idea here is to get the input back from the output. Let's see if it works. If I plug in -1 from this side, then -1 plus 1 is 0. 0 divided by 2 is 0. That's correct. So we get f inverse of -1 is equal to 0. Do you see that? That's how we will write it. So inverse is written as -1. So let me write f inverse. Now f1, let's check. If I plug in 1 here, add 1 to 1, it becomes 2. And 2 divided by 2 is 1. You get 1. That's correct. So f inverse of 1 is 1, correct? We can try with 2. Now, f2 was 3. So if I plug in 3 here, 3 plus 1 is 4. And 4 divided by 2 is 2. So we get f inverse of 3 as 2. So make a note of how I am writing it, right? Now the input was 3, right? And the output is 2. So f inverse of 3 is 2. Let's plug in 19 this time. So if I plug in 19, 19 plus 1 is 20. And 20 divided by 2 is 10. So f inverse of 19 is 10. So we'll write this as f inverse of 19 is equals to 10. Do you see that? What did this machine do? It did an operation first while going, which was times 2 minus 1. And for inverse, we did the reverse operation. That is plus 1 instead of minus 1 and divide by 2 instead of times 2 to get our result back. That is what is really a concept behind inverse function. I hope you appreciate it. And in a nutshell, I can summarize this with a very simple thing. That is, I can write this all as, if I do f inverse of a function, that is f of x, which I did, right? This is f of x and I did the inverse. What output do I get? I get my input back. I get my x back. Do you see that whole operation? So that is very important criteria, right? Either way it works. It works even if I do function first and then inverse. So this will also give me the output. This will also give me back the same result, right? So that is what it is all about. So what we're trying to achieve here is, if you give an input, then you get an output. But if you get the output inside, then what should you get out? You should get out with the original input. And that is the performance of inverse function. So in a nutshell, inverse function reverses the operation, and since inverse function reverses the operation, we can find inverse of a function by reversal of operation. So can I write down my answer now? What is the inverse of this function? So inverse of this function is equals to, what should we do with x? First add 1, then divide by 2. Do you see that? So first add 1 and then divide by 2. This is the inverse of your given function. Reverse operation. 2x add 1 divide by 2, right? Which you could also write as half of x plus half, right? But that is the basic. So I hope with this example the concept is clear. Now we will do inverse function with reversal of operations and see whether you really get the concept or not. Thank you and all the best.